Uh-huh. You're pretty good at it.
Thanks. Ashley, is your mom just hanging out at your apartment? Yeah, she's been there since Friday. Why? She brought my couch up, and then I called her on Sunday morning just because I have like a video walkthrough of my apartment, but then it like deleted, so I was like asking her to just like send me one so I can like figure out like what I like need and stuff. And I called her on Sunday morning. I was like, "Hey, like, what are you doing?" She said, "Oh, I'm out to eat with your brothers." I was like, "Oh, aren't you like coming home today?" No, I don't know when I'm coming home yet. Okay. So I called her Monday morning and I was like, "Hey, like, since you're probably like leaving today, like, don't forget to send me that video." Call her at lunch, and then she's like, "Oh, I'm just about to hop on my meeting." I was like, "When are you coming home?" I think she's probably on her way now, but or she's just gonna live there forever. Yeah.
Yeah.
She's actually just gonna switch with you. She did post on her Snapchat story last night a picture of out my window and goes, "I could look at this forever." And I was like, "No."
All right. At the beginning of the year, the power plant had a supply of 1,200 tons of biofuel to burn. The function B is an increasing function and models the total amount of biofuel that the power plant has and satisfies the differential equation. Yeah. B is measured in tons and T is measured in the number of years. T is the number of years after this year. Use the line tangent to the graph of B at T equals 0 to approximate the amount of time the biofuel that the power plant has at the end of the first 4 months. Time equals 1/3. So if we put the time in here, all right. So for this one, ooh. All right. I wonder if so at the start of the year, it has 1,200 tons of biofuel. So at time equals 0, the amount of biofuel is 1,200. So the slope, dB dt, equals 3/50 times 1,200 minus 200, or 3/50 of 1,000. 100 over 5 is 20, so 3 times 20 is 60. So the slope is 60 at time equals 0. Okay, so the tangent line is y equals 60x plus plus whatever time equals, or plus, and then would it be be 1,200 at time equals 0? Okay, because this is the slope. The slope is 60. Oh, I should put that as t. Okay. All right, so that's a line. That's a tangent line there because this is a slope, which we figured out to be 60. This is the y-intercept, which is 1,200, which is time equals 0. So at time equals 1/3 the first 4 months, y equals 60 times 1/3 plus 1,200. So y equals 20 plus 1,200, or 1,220 tons. So that's what A would be. Then we're supposed to find the second derivative of this. So the second derivative of this, db squared, or d squared b over dt squared equals, basically it's 3/50. If we take this and distribute, it's 3/50 b minus 200 minus 12, right? So if we take the first derivative of that, it'd be 3/50 would be the second derivative, right? 3/50. Oh, little Khan Academy work there, huh? All right. So we have to do, if dB over dt equals 3/50 times b minus 200, we have to do differential equations to find the derivative. So dB over b minus 200 equals 3/50 dt. Or was I right? No, that, what am I doing? That's the integration. That's, oh. The second derivative of that. So the second derivative of this, d squared b dt squared equals 3/50 with respect to t. Why am I having a brain fart? Three-fiftieths, there we go, dB dt. Because you have to take the derivative of b with respect to t. There we go. So the second derivative is 3/50 times 3/50 times b minus 200, which is 9/2500 times b minus 200. There we go. Okay, so that's the second derivative. So if that's the second derivative of it, then we need to know if it's concave up or concave down to figure out if it's an underestimate or overestimate. So if we look at this and set it equal to 0 to find a point of inflection, b would equal 200, would be a point of inflection. Yeah. I would just swag it if I were you at this point for B. B, I don't like that question at all. Particular solution. When you see particular solution, that's when you integrate. So you have to get the B's to one side and the T's to one side and integrate both sides. So this is the ln of B minus 200 equals 3/50 T plus C. Okay? And if the condition is B of 0 equals 1200, at time equals 0, this is 1200. At time 0, this is 1200. So the ln of 1200 minus 200 equals 3/50 times 0 plus C. So the ln of 1000 equals C. So if the ln of 1000 equals C, then we know that if we want to solve for B, the ln of B minus 200 equals 3/50 T plus the ln of 1000. So we have to E both sides. So B minus 200 equals E to the 3/50 T, and then it's E to that, so times E to the ln of 1000. So B minus 200 equals E to the, or basically 1000 E to the 3/50 T. So B would equal 1000 E to the 3/50 T plus 200. And there we go. That's a particular solution. Okay? All right. 2 left. Find the x-coordinates of the relative minimum and maximum and justify your answer. When you see relative minimum and maximum, it is derivative. First derivative of the function equals negative 15 plus 18x minus 3x squared. Factor out a negative 3, and you get x squared minus 6x plus 5 equals 0. So it's x minus 1, x minus 5 equals 0. So x equals 1 and 5. So then if you plug them into the original function, if you find f of 1 equals 2 minus 15 plus 9 minus 1. 2 minus 15 is negative 13. Plus 8 is like a negative 5. F of 5 is 2 minus 75 plus 9 times 25 is 225 minus 5 cubed is 125. So that's 100. And this is negative 73 plus 100 is like 27. So this would be a relative max, and this would be a relative min. Okay, the x and y coordinates. So the relative min would be at negative, or it would be at 1, negative 5. The relative max would be at 5, 27. And just by knowing that, you should get probably 3 points. The equation of the line normal there. So the line normal is the perpendicular line to the tangent line at 2, 0. So you have to figure out the slope at 2, 0. So if you take the first derivative at 2, if you stick 2 into the first derivative, you get negative 15 plus 36 minus 12, which is 9. So the slope at x equals 2 is 9. So if 9 is the slope of the tangent, the slope of the normal would be 1/9. Okay, the slope of the normal is 1/9. Am I on the right track? Yep, or negative 1/9, excuse me, negative 1/9. So then y minus the y value of that point, which is 0, equals negative 1/9 times x minus the x value of 2. So y equals negative 1/9 x plus 2/9. That's the equation of the line normal to 2, 0. Okay. And then find the x and y coordinates of the points of inflection. Points of inflection have to deal with the second derivative. So the second derivative is 18 minus 6x, so that equals 0. X equals 3 is your point. Is a point of inflection, so stick 3 into the original function. So f of 3 equals 2 minus 45 plus 27 minus 27. So it would be at 43. So the x and y coordinate would be 243 of the point of inflection. No, 3. Stick a 3 in there. 343. And they get 311, so I didn't make a math error. Oh, this is 81. There we go. So 2 minus 45 is negative 43, plus 81 minus 27 is 11, 311. So yeah, I would have missed a point there because I made a stupid math error. Okay, but I would have gotten 8 of my 9 points there. Okay. And then velocity of a particle. Find the position at s equals 3. When you're finding position, what is it? Of the velocity? Integral. The integral of v sub t. If you write that down, you automatically get a point. T cubed minus 6t squared plus 9t plus c. If s of 3 equals 0. So 0 is equal to 3 cubed minus 6 times 3 squared plus 9 times 3. So 0 equals 27, plus c, 27 minus 54 plus 27 plus c. So c equals 0. So the position function is s of t equals t cubed minus 6t squared plus 9t plus 0, or just that. That's part A. Part B, when is the particle moving forward? So when is the velocity positive? So you have to take the velocity function, which is 3t squared minus 12t plus 9. Set equals 0. to find where it changes velocity from positive to negative. So if you factor out a 3, you get t squared minus 4t plus 3 equals 0. So t minus 3 and t minus 1 equals 0. So t equals 1, t equals 3. So here's 0, 1, 2, 3, 4. Okay. So if we put 2 into the velocity function, we get 12 minus 24, which is negative 12, plus 9 is negative 3. So we're negative here. So we're positive here, and we'd be positive here. Okay? So a positive, negative, positive velocity. So it asks, where is the particle moving forward? Well, from time equals from 0 to 1, and from 3 to infinity, it would be moving forward. Okay. Am I right there? Yep. And then finally, what's the distance traveled in the first 5 seconds? When you're finding distance traveled, it's the integral of the first 5 seconds of the velocity. Or the absolute value of the velocity. So and what they did is they just found the change in position divided by the change in time, or change in position to find distance, which would make sense. Because from 0 to 1, if you stick so if we take the integral from 0 to 1, or actually just change in position from 0 to 1. So the position s of 0 equals s of 0 equals 0. S of 1 is 1 minus 6 plus 9, which is 2. 1 minus 6 plus 9 should be 2. They have 4, so where did I go wrong? One minus 6 is negative 5 plus 9 is 4. And then, so the distance traveled between 0 and 1 seconds is 4. Between 1 and 3 seconds, so the position at 3 seconds is 27 minus 54, which is negative 27. That's like 0. So from 0 to 4, so from 1 to 3 seconds, it also goes 4. And the position at 5 seconds is 125 minus 150 is negative 25, plus 45 is like 20. So it goes from 0 to 20, so it goes another 20 from 3 to 5. So it would be 28 meters it travels because of the change in distances. Okay? And there we go. So just some things to look at. Getting ready for tomorrow's or Thursday's diagnostic. those are some things that you see on a lot of them, a lot of these tests. So just do your best. I'll give you points. Hopefully things go well.